How do externalities affect us? For the topic of externalities, we asked 3 Griffith University economics students how externalities affect them.
I think of myself as a student because I'm not the only one benefiting from me educating myself. For example, future employers is going to benefit from me being more skilled as a worker, so they can take advantage more of my skills. Also, the whole labor force as a whole will be more skilled if more people educate themselves. And also, me as a student and as an educated person will statistically earn more money than someone who's not as educated, which will in turn bring more tax revenue to the government, who will be able to improve society as a whole with that money.
When I think of externalities, I think about when I put fuel in the car. I pay the price of the fuel and the supplier receives the money for that. But neither of us may be accounting for how much traffic is created. If I was to put $5 of fuel in my car one week, but then need to put $20 of fuel in my car the next week, and a lot of other drivers do the same thing, a lot more traffic and congestion could be created, but that's not really captured in the price of petrol. So that's an example of a negative externality that could occur.
Living in surface paradise myself and having a nice view for the ocean, I think of a negative externality that could occur if a developer would, say, buy a piece of land nearby and build a building right in front of mine, reducing my beautiful view on the ocean, and then neither him nor the people who would move into that new place would actually bear the costs of my place losing value.
So how can we model these scenarios with fancy, intelligent-sounding economics terms? The term we'll be using, which we already stated, is externalities. Externalities can be positive or negative, or sometimes both. We'll focus on a negative externality and show how the social cost of traffic can be illustrated in a graph.
This clip is, as you know, looking at externalities, and just a couple of comments about the economics of externalities. As in the lectures, in the next little section here, you're going to see a demonstration of how taxation can be used to minimize the impact of externalities, negative externalities in this case. If it was positive externalities, it might be that subsidies are offered to suppliers. Notice that the taxation, of course, can be applied to both the purchase side and the supply side. But we do need to point out that in lots of cases, taxation and subsidisation are not the answer. They're just not good mechanisms for dealing with externalities. We've mentioned roads and congestion on roads as an externality, a negative one. Let's think about a stream of traffic which then intersects with another stream of traffic. They both have their own congestion levels, but at crossroads where they intersect, that set of two externalities really becomes one and becomes massively intensified. The externalities that are created there can't be appropriately dealt with by any kind of economic mechanism. What we do then is have rules of the road, and sometimes those won't work as well if the traffic is too heavy. So we have another mechanism, and that might be traffic lights. So don't think immediately, because there are externalities, that there must immediately be an economic mechanism that will resolve it. That's not always the case.
To illustrate a negative externality, we'll start by drawing our usual supply and demand graph for a market. That market could be student loans or high-rise apartments in Surfers Paradise, but we'll focus on unleaded fuel for cars. The price is measured on the y-axis and the quantity traded is on the x-axis. In normal equilibrium, we find the market price and market quantity aligns with the supply and demand curves cross. So our graph looks the same. However, we can add a detail to our market curves and consider them to be the private demand and private supply for the product. This means that it is the market price and quantity agreed by private transactions and doesn't account for indirect effects on third parties that the transactions may create. To account for these externalities, we are going to add a social demand curve. This curve reflects how consumers would be willing to purchase the product with the social cost included. If everyone was worried about traffic, then the demand would drop. We can see that when the social cost is included, a new equilibrium is created with a lower quantity and a lower price. This shows that if a motorist accounts for the added traffic of fuel sales, then the lower quantity and lower price is more socially agreeable. In economics, we like to start simple and develop ideas with more complexity as we analyse them. In this scenario, we have looked at how the negative effect of traffic and congestion can change the market for car fuel, but haven't added specific prices or quantities because measuring externalities can be difficult. To measure the lost productivity from late workers stuck in traffic, extra fuel consumption from stopping and starting cars, and the expense of a new plane ticket when you miss a budget, non-refundable peak hour flight would be difficult. The social cost could be estimated, but it takes a lot of research and data collection. The responses to externalities need to be considered as well. Negative externalities can be corrected by taxes or tariffs, and positive externalities can be encouraged with subsidies, promotions, or grants. There can also be multiple externalities, such as increased traffic also causing more pollution. Understanding the third-party costs associated with externalities is the first piece of the puzzle to understanding them and how they can be corrected.
In the introductory video, what was mentioned was a toll road, and the idea of a toll road and a free road running exactly the same distance right next door to each other, exactly the same surface and so on, going between exactly the 2 points. So nothing at all to choose between them. So what I've done here is try to combine what happens when the two are in operation and what difference the toll road price might make to the way they operate. And one of the things that we're going to see is that the two roads interact with each other, and in the case of the toll road, it provides a positive externality for the free road users. So both roads will have congestion, but the two do interact with each other. So let's look at the diagram now, which I've already partially constructed, and we're going to assume that the total amount of traffic that the two roads combined will be Q. Now that's definitely a simplification, because in the real world, if you add another road, what will happen is that you won't get exactly a doubling of traffic. There may be more than a doubling, much more likely will be less. But let's assume that there is a set amount of traffic, quantity Q, going over the free road before the toll road is constructed, and that the toll road, its existence, doesn't increase the traffic in any way, shape or form. It just provides an alternative. Now, what I've got here is the demand curve for the toll road based on a situation where the toll road is free. In other words, it becomes another free road. And here, the price or the toll at which nobody will use the toll road. It's too expensive. So I've just arbitrarily drawn the demand curve that shape. So this, remember, is the demand curve for the toll road based on the toll that's charged, running from a zero toll, which means that half of the traffic will use the toll road now that it's free, and the other half of the traffic, which will add on to that to make it up to the total amount Q, will use the free road. As the price goes up, less and less people will use the toll road. What this means then is that we have a situation where as less and less use the toll road as the price goes up, more and more they'll be using the free road. So it will look like this. So essentially I'm trying to draw the mirror image of the toll road's demand curve. So if you add, say, at this price, P1, that amount on the toll road, that amount of traffic, that amount of traffic on the free road, then those two added together will equal Q. That's all the way along. So what happens is that the price not only determines the traffic on the toll road, but it also determines the traffic on the free road. The market for the toll road provides a positive externality for the free road. What does the free road do? The free road also provides a positive externality for the users of the toll road. It gives an alternative where people who don't want to pay will go.